This segment of the video will focus on predicting products for organic reactions. There are four major kinds of organic reactions that we'll be dealing with today. Those are oxidation, substitution, esterification, and addition. Oxidation is most commonly the combustion of a hydrocarbon in the presence of O2. If it's complete combustion, it will completely form CO2 and H2O as products. Milder oxidations will cause, if a primary alcohol is being oxidized, it will produce an aldehyde, and if a secondary alcohol is being oxidized, and a ketone is produced. For more on the combustion, you see the combustion section of this video. Substitution is switching a hydrogen in a hydrocarbon for another atom or molecule. Esterification is the combination of an organic acid and alcohol to produce an ester and O2. An ester they tend to have a sweet smell to them, which is contrasting to their carboxylic acid parent, which has a rather pungent smell. And a common ester is the medication used for aspirin, and and then finally, addition is the breaking of a carbon double bond into a single bond, and then the addition of atoms to each of the affected carbons that have a double bond broken. An example of substitution is the reaction between C2H4 and Br2. We'll undergo a reaction to form C2H3Br and hydrobromic acid. While this is a rather simplistic example, it is, for a rather simplistic reaction, it is just taking one of the reacting agents that is not the organic substance and replacing one of those with a hydrogen, and placing in that hydrogen's place you add what you have removed. In this case, you switched one of the BRs and Br2 with a hydrogen to form hydrobromic acid. In that hydrogen's place, you place the Br. In an addition reaction, you break the double bond between two carbons, change it to a single bond, and whatever you are adding to it, you break your additional molecule into two parts and add part of it to each hydrogen. In the reaction shown between C2H4 and H2O, the double bond between the two carbons in the C2H4 has been reduced to a single bond, and the bond in H2O has been broken to an H and an OH group. You add an H to one of the hydrogen to one of the carbons, and the hydroxide to the other carbon, creating CH3CH2OH as your product. It does not always have to be in addition to water. You can also add bromine to it, so you'll just be adding a bromine to each carbon instead of a hydrogen and an OH. In the reaction esterification, you have the reaction between an organic acid, in this case we have acetic acid, reacts with an alcohol. In this example we have ethanol, to produce an ester, seen here, and H2O. The reaction between the acid and the alcohol will occur between the two hydroxide groups, with the hydroxide on the acid reacting with the hydrogen of the hydroxide group on the alcohol to produce the water, with the remaining oxygen from the alcohol bonding to the carbon of the carboxyl group on the acid to produce your final ester. And that is organic predicting products in a nutshell.
And then this is the combustion part of it. Typically you're either going to use a hydrocarbon or a carbohydrate, react it with oxygen, and you're always going to make carbon dioxide and water. And for the purposes of the AP exam, you're not going to worry about incomplete combustion, so you're just going to assume that.